Thank you for coming to my talk titled EmuOCPP, Effective and Scalable OCPP Security and Privacy Testing. This is a joint work with Soumaya and Victor, Thomas Barber, and myself. We are a team from EURECOM, which is a university based in the southern part of France, and also a SAP research in Munich. So let's set the stage. Here we are talking about electric vehicle charging networks, where you have electric vehicles here on the left, and then you have some charging stations. You have some charging station management system, and then there is a communication link in between the charging station and the management system, which talks a protocol called OCPP, the Open Charge Point Protocol. OCPP is a standard, and being a standard is interoperable, so you can find OCPP packets in whatever charging infrastructure. It is a client-server protocol where the charging station is the client, the management system is the server. It is an application layer protocol which is relying on standard internet-based technologies. In fact, it is transported over WebSockets, which provides bidirectional communication, and it is message-based. And so the client is sending a message and then is getting a response from the server. It is a version protocol, and latest version is 2.0.1, and it provides many features about charging, including authentication, billing, firmware updates for the charging stations, charge control, and so on and so forth. Regarding security, OCPP is standardizing something called security profiles. So there are three security profiles. The first one is a kind of misnomer because it is not secure at all. If you use security profile 1, the charging station is authenticating to the management system with a password, but the communication link is completely open. It's unencrypted, not authenticated, and so anyone can sniff the password, and so on and so forth. And there is no TLS, and the management system is not authenticated. If you upgrade to SP2, then you get the management system authentication using TLS and a certificate. So you contact the management system from the charging station, you get the certificate, you authenticate that certificate, you establish a secure link using TLS, and then you can authenticate with a username and a password. And this looks like the typical online authentication scheme. Whenever you go to facebook.com, you do something similar. And then there is SP3, which should be the strongest, where also the client, the charging station, is upgrading to certificate-based authentication. And so here you have TLS, mutually authenticated with client and server certificates. And the security and privacy of OCPP is really important, because there are many security and privacy implications if you break an OCPP network. In this network, you can find messages that are carrying sensitive data about the user, including locations, addresses, maybe credit card numbers, authentication tokens. You can also find firmware updates flowing in this network. And so if you're able to capture a firmware or maybe modify the firmware while it is uploaded, you can create really bad situations widespread. And this is a remote attack surface, because here we are talking about something that is internet connected, right? There is a large-scale impact associated with OCPP security and privacy because OCPP is a standard. And so if you break a standard protocol, then you can target whatever device is using this standard protocol. This is just an example of attacks that you can mount. If you break OCPP, you can mount a man-in-the-middle attack, eavesdropping attacks, impersonation, and denial of service. And this is what we will see next, some of these real-world attacks that we performed. So the importance of OCPP security and privacy motivated our work, and we looked at the state of the art about OCPP security testing, and we found several tools. One is called OCTT. This is a proprietary tool that is provided by the OCPP organization, is under a paywall, and is mostly testing compliance. So this is not good for security and privacy. Then there is OCPP Storm. This is a research paper implementing a fuzzer, focusing on implementation bugs on a specific OCPP version, like version 2.0.1. And then there is Check OCPP, which is an open source compliance checker that we developed. And this was a building block to design the EmuOCPP. And so looking at the state of the art, we quickly realized that there is a need for a security and privacy testing framework for OCPP. And then we set the following requirements, also based on the state of the art. We wanted a testing framework that supports all OCPP versions, 1.6, 2.0, 2.0.1, and future ones, supports all security profiles, quickly discovers vulnerabilities and attacks, and even new ones. The framework should cover all sorts of vulnerabilities related to OCPP, so design vulnerabilities, implementation vulnerabilities, and also it should cover security and privacy. And this is exactly what we are presenting with this paper, EmuOCPP. This is a new testing framework that we are open sourcing on GitHub, and we use this framework to test real-world OCPP deployments, and we found 8 attacks, 5 of which are new. And these attacks include man-in-the-middle, eavesdropping, impersonation, denial of service. Our attacks are covering all OCPP versions and security profiles, and so we estimate an impact of in the order of millions, maybe even billions of devices. We evaluated the attacks on 9 popular implementations, open source and proprietary, and as we will see later, all of them are vulnerable to all the attacks that we found. And also we responsibly disclosed the attacks to the OCA. This is the body maintaining the OCPP specification. They were really nice. We are not expecting that because we are quite used with responsible disclosures, and typically vendors, they shy away, especially if you disclose to big consortiums. In this case, they were really responsive. We had a meeting with them. They acknowledged our findings. They improved the OCPP specification because of our findings. And they also changed the test suite in the compliance tool that I discussed before to test some of our attacks. So this is really top-notch research results. Let's see some design bits of EmuOCPP. As you can tell from the name, EmuOCPP is an emulator for OCPP. Which allows to test these attacks without having to buy the equipment. You can just run an emulated OCPP network in your laptop, or you can also scale it if you want, and then you can test several things. You run real OCPP stacks in this emulation environment. The emulation environment is based on containers, so every single container is representing a network host that can run real code that is generating real packets. Then you are inside the network. You can put the attacker wherever you want. As you can see here, we are putting the attacker as a man-in-the-middle / eavesdropper between an emulated charging station and an emulated management system. And we can set for each link the security profile that we want to test and also the OCPP version. So this is really flexible, really powerful, because we can test all possible combinations of versions and security profiles. For example, if you remember, security profile 1 is unsecure by default. And so for that attacker, the man-in-the-middling and eavesdropping that link is trivial because there is no TLS going on. Instead, at the bottom of the figure, there is an impersonator who is trying to impersonate a charging station to a management system in a link with the latest version of OCPP, and now there is security profile 2 in place. And so this impersonation attack is slightly more complicated because the attacker will have to provide a certificate. As I said, this emulation design strategy allows you to emulate a really complex OCP network with thousands of hosts, thousands of charging stations and management systems in your laptop. We also support the most popular OCPP messages. If you remember, this is an application layer protocol, which is based on messages. And so we use open source libraries to support these messages, and then we can test whatever we want. We can test heartbeat, boot notification, authorization messages. We can test security critical messages, including ones signing certificates, installing certificates on the network, and so on and so forth. We also have a nice configuration, which is YAML based, but we also provide the GUI if you want to set up your network. And now let's look at the attacks. So we used EmuOCPP to perform an extensive security and privacy evaluation of the OCPP standard, and we found 8 attacks. The attacks boxed in blue are the new ones. So there are 4 man-in-the-middle attacks. The first one is trivial. It is a man-in-the-middle on security profile 1, which is not secure. But the other 3 man-in-the-middles are not trivial at all, because we found ways to exploit the security profile upgrade mechanism to install our own certificates, and then being able to man in the middle and impersonate devices. We also found eavesdropping attacks, which were also trivial because we were attacking security profile 1. We found the denial of service attack that can be mounted to in a distributed manner to denial of service and take down the full OCPP network. And also we found 2 impersonation attacks, which are taking advantage of a mix of design and implementation vulnerabilities on the protocol. And as you can see from the table, the attacks are exploiting vulnerabilities at the design level. If you look at the type column, there is DES and IMP. So we are finding and exploiting vulnerabilities at the design and implementation level. Design, by design, I mean the protocol specification. The implementation vulnerability instead is targeting a protocol that is misimplemented. And we see that we exploit all security profiles from the OCPP SP column, all versions. We see that the attacks impact both security and privacy, and then we see also what is the underlying vulnerability of the attack. For example, the 3 novel man-in-the-middle attacks are exploiting vulnerabilities, new vulnerabilities that we found in the security profile upgrade process, and also a vulnerability we found in the security profile downgrade logic. And the other 2 novel attacks are exploiting novel vulnerabilities that we found where there is an undefined behavior whenever you set an ID of a charging station. This ID, if it is not properly checked, enables to impersonate charging stations. And also, we found a vulnerability that enables tracking of a charging station. Now we will see 2 concrete examples of this attack. This M2, a man-in-the-middle attack on SP2 upgrade. So here the devices they want to secure their communication using TLS. They are running SP1. But if an attacker is in the middle, the attacker can follow the establishment of a WebSocket connection. Then there is a message called boot process that is bootstrapping the connection. But now the attacker, before the management system is able to install a valid certificate on the charging station, the attacker can install their own certificate on the charging station. And the charging station will happily accept the attacker certificate, and now the attacker can spoof a management system using this trick. And after this protocol is run, the charging station and the management system, they think that they upgraded to a secure version, but the attacker is still in the middle. And this is really bad, because if you are in the middle, you can do whatever you want. This is a second example of an attack where we are man-in-the-middling the security profile 3 with a downgrade attack. So in this case, we are preventing the charging station from using a secure profile by sending and blocking requests to use a security profile. And so by doing that, we can downgrade from security profile 3 to security profile 1, and then we establish an insecure link using a downgrade attack. We evaluated the attacks on 6 popular OCPP implementations. The one from Mobility House that is also used by our emulator. This is open source. This is the state-of-the-art implementation, which is also used by vendors. We also evaluated Steve, OpenEmobility, OpenEVSE, OCPP Core, and we also evaluated a production charging network put in production by SAP. And as you can see from our evaluation results, all the targets that we evaluated are vulnerable to all the attacks that EmuOCPP found. There are some NAs because the feature we were trying to exploit was not implemented at the time of the experiments. And there are also some crosses because sometimes an implementation is mitigating some of our attacks because of some implementation strategy. But yeah, this table demonstrates that the attack have a critical impact on the OCPP ecosystem. And yeah, and that's it. So I'm happy to take questions, and thank you for your